While we talk about the IoT, some of the factors that drive the IoT applications need to be talked about. So these applications basically um, drive the user towards the IoT, and the factors affecting them are crucial in the success of the IoT. So the first thing that we should talk about is the sensor types. So we say that the base of the IoT is basically connecting the sensors, deriving the data, and then pushing to the cloud, right? So every data uh, is not unique. So the s- data that is generated at the ground level, that is at the sensor level, or basically we call the device level, have different types of sensors, and different formats that come out of the sensors. So we have to read the data and process that data to get to a proper format. So that is a very important factor. And mm, IoT, most of the times, especially in the commercial applications, is cost sensitive. So the sensors cannot be used just like that to derive the data. Cost plays a very crucial role. So while developing an IoT application, one of the thing that need to be considered predominantly is what are the types of sensors that need to be used, and what kind of data that we are deriving out of them. And second point, the IoT application can be implemented at various places. Like example, it could be a smart city, it could be a smart agriculture, it could be a smart cars, right? The autonomous cars, basically. Uh, so, or the connected cars, anything that is driving the IoT application is driven requires wireless options. So, if we are in a place where there is availability of different WLAN options like the Wi-Fi or the BLE to connect, it's very easy to drive the application. But when we are in places which are remote, the options like 4G, 5G play a role. If there are places where we don't even have that 4G and 5G, options like LoRa play a role there. So the wireless options that we are considering, and again the cost associated with implementing them at the PCB level, play a very crucial role. So we talked about the wireless options, we talked about the sensors. So all these sensors data will be pushed to a specific controller or a processor, and then we interface it to a wireless option which further drives the data to a gateway or to a edge component. Now, these processors or microcontrollers are the things which drive the complexity of the board. If a particular application can be achieved with a simple microcontroller plus wireless option, it is the best thing to go. Or if you need more computing to be done at the base level, even before reaching the edge, complex processors are required. Especially the gateways that are used in IoT have a complex processor related boards, which are, as we said, complex compared to the ground level processing devices where we connect sensors. And the next thing is the power consumption. This is a very crucial role. Most of the IoT devices operate on batteries. So, option to operate them on batteries and having a very good life for the batteries is a crucial factor. Places where you have a continuous DC supply from either AC to DC adapter or some other means might not be a challenging, and this might be the case where you might have industrial IoT applications. But when we go to a remote places, battery is the option which we need to consider. So power consumption of the devices is a very crucial factor. So hardware engineers who work specifically in the IoT applications need to understand these power consumption capabilities, and do a power consumption calculation on the board and come up with the amount of power consumed, and need to decide which devices need to be put in the lowest power mode, like the sleep modes, and when to wake up, when to transmit the data. This is a very big challenge for the designers, and power consumption covers all these aspects. And in an IoT, especially the edge computing capabilities, where even before going to the cloud, the data need to be analyzed at the edge, and this requires powerful edge computing devices. And we have a lot of system on module kind of devices these days which can perform these activities for us. And then AI is playing a very crucial role. For example, when we try to send data from various sensors, analyzing the data and coming up with a specific analytics for that particular data uh, is dependent on the AI models that are being implemented, especially at edge devices and also at the cloud level. So this particular AI models these days play a very crucial role in the IoT applications. So user who is working on the firmware for IoT cannot just be a simple integrator of the firmware or a simple driver level guy. He should also understand the intelligence associated with the application and implement intelligence into the devices. So that's where implementing the IO models come into picture. And another point is more on cloud integration, where data is integrated into the cloud, and we do have data that is being analyzed and analytics generated, which is further driven down to the level of applications like smart cities, smart um, cars, or whatever, or agricultural related needs. So all these analytics will be generated at the cloud level, and the integration, uh, cloud integration into an IoT application and identifying the right cloud strategy is a very important for an IoT engineer. And data analytics play a very crucial role in taking decisions as per the application demands of the IoT. So these factors drive the IoT applications, and there are several at the minute level, but at a very high level, these are the factors which drive the IoT applications.